Chapter Environmental Chemistry. As you can see, this is my NCERT textbook, and let us start. Okay, first of all, atmospheric pollution. The lowest region of the atmosphere in which human beings along with other organisms live is called the troposphere. It is the lowest layer. It extends up to the height of 10 km from sea level. Above the troposphere, between 10 to 50 km above the sea level, lies the stratosphere. Troposphere is turbulent, dusty zone containing air, much water vapor and clouds, and it contains dinitrogen, dioxygen, ozone and little water vapor. Now let us study about tropospheric pollution. First, there are 2 points in that. One is gaseous air pollutants. These are the oxides of sulfur, nitrogen, carbon, hydrogen sulfide, hydrocarbons, ozone and other oxidants. Then what is particulate pollutants in that? There are dust, mist, fumes, smoke and smog. Now let's study about gaseous air pollutants, oxides of sulfur and some other topic, oxides of sulfur, oxides of nitrogen and hydrocarbons, oxides of carbon and carbon dioxide. Yes, that's it. Now let's study about oxides of carbon. See, oxides of sulfur are produced when sulfur containing fossil fuels are burned. The most common species, that is sulfur dioxide, is a gas that is poisonous to both animals and plants. It has been reported that a low concentration of sulfur dioxide causes respiratory disease, example asthma, bronchitis, emphysema in humans beings. Sulfur dioxide causes irritation to eyes resulting in tears and redness. High concentration of sulfur dioxide leads to stiffness in flower buds which eventually fall off some flowers. And uncatalyzed oxidation of sulfur dioxide is slow. However, the presence of particulate matter in polluted air catalyzes the oxidation of sulfur dioxide to sulfur dioxide, and this is the reaction, that is 2SO2 plus O2 gives 3SO3, that is sulfur dioxide. The reaction can also be promoted by ozone and hydrogen peroxide, like ozone and hydrogen peroxide. Same thing is formed. Then oxides of nitrogen. See, dinitrogen and dioxygen are the main constituents in the air. These gases do not react with each other at normal temperature. At high altitudes, when lightning strikes, they combine from oxides of nitrogen. NO2 is oxidized to nitrate ion NO3 minus, which is washed into the soil, where it serves as a fertilizer in an automobile engine. At high temperature, when fossil fuel is burned, dinitrogen and dioxygen combine to yield significant quantities of nitric oxide and nitrogen dioxide, which is given as here below. N2 plus O2 in the presence of this temperature gives 2NO. NO reacts instantaneously with oxygen to give NO2. 2NO plus O2 gives 2NO2. Rate of production of NO2 is faster when nitric oxide reacts with ozone in the stratosphere, and the reaction is given below. The irritant red haze in traffic and congested places is due to the oxides of nitrogen. Higher concentration of NO2 damages the leaves of plants and retards the rate of photosynthesis. Nitrogen dioxide is a lung irritant and can lead to acute respiratory disease in children. It is toxic to living tissues. Also, nitrogen dioxide is also harmful to various textile materials. Okay, hydrocarbons. Hydrocarbons are carcinogenic, that is, they cause cancer. They harm plants by causing aging, breakdown of tissue, and shedding of leaves and flowers and twigs. Now let us come to oxides of carbon, that is carbon monoxide and carbon dioxide. Carbon monoxide, is one of the most serious air pollutant. It is colorless and odorless gas, highly poisonous to living beings because of its ability to block the delivery of oxygen to organs and tissue. It is produced as a result of incomplete combustion of carbon. Carbon monoxide is mainly released into the air by automobile exhaust. Other sources which produce carbon monoxide involve incomplete combustion of coal, firewood, petrol, etc. The number of vehicles has been increased over the years. It binds to hemoglobin to form carboxyhemoglobin, which is about 300 times more stable than oxygen hemoglobin complex. In blood, when the concentration of carboxyhemoglobin reaches to about 3 to 4%, the oxygen carrying capacity of blood is greatly reduced. This oxygen deficiency results into headache, weak eyesight, nervousness, and cardiovascular disorders. Here, nervousness is not anxiety; it is a nerve problem. This is the reason why people are advised not to smoke. In pregnant women who have the habit of smoking, the increased CO level in the blood may induce premature birth. Premature birth is when baby comes before the trimester, that is before 9 months. Spontaneous abortion, just incomplete baby comes out, and deformed babies, of course. Now, carbon dioxide is released into the atmosphere by respiration, burning of fossil fuels for energy, and decomposition of limestone during manufacture of cement. It is also emitted during volcanic eruption. Okay, carbon dioxide gas is confined to troposphere only. Normally, it forms about 0.03% of the volume of the atmosphere. With increased use of fossil fuels, a large amount of carbon dioxide gets released into the atmosphere. Excess of CO2 in air is removed by green plants, and this maintains an appropriate level of CO2 in the atmosphere. Green plants require CO2 for photosynthesis, and they in turn emit oxygen, thus maintaining the delicate balance. As you know, deforestation and burning of fossil fuel increases the CO2 level and disturbs the balance in the atmosphere. The increased amount of CO2 in air is mainly responsible for global warming. Now let us study the next topic, that is global warming and greenhouse effect. See, about 75% of the solar energy reaching the earth is absorbed by the Earth's surface, which increases its temperature. Okay, the rest of the heat radiates back to the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, chlorofluorocarbons, that is CFC, and water vapor in the atmosphere. Thus, they add to the heating of the atmosphere. This causes global warming. Now, just as the glass in the greenhouse is covered with glass in the greenhouse holds the sun's warmth inside. The atmosphere traps the sun's heat near the earth's surface and keeps it warm. This is known as natural greenhouse effect. It is natural greenhouse effect because it maintains the temperature and makes the earth a perfect life. If the amount of the carbon dioxide crosses the delicate proportion, and that is of 0.03%, the natural greenhouse balance may get disturbed, and the carbon dioxide is a major contributor of global warming, as you know. Besides carbon dioxide, other greenhouse gases are methane, water vapor, nitrous oxide, CFC, and ozone. Okay, methane is produced naturally when vegetation is burnt and digested or rotted in the absence of oxygen. Large amounts of methane are released in the paddy fields, coal mines, from rotting garbage dumps by fossil chlorofluorocarbon, that is CFCs, are man-made industrial chemicals used in air conditioning. Now, CFCs are also damaging the ozone layer. Nitrous oxide occurs naturally in the environment. In recent years, their quantities have increased significantly due to the use of chemical fertilizer and burning of fossil fuel. If this trend continues, the average global temperature will increase to a level that might lead to melting of polar ice cap and flooding of lower lying areas all over the earth. Increase in global temperature increases the incidence of infectious disease like dengue, malaria, yellow fever, and sleeping sickness. Okay, I hope you understood this. Now let us come to acid rain. You are aware that normally rainwater has pH of 5.6 due to the presence of H plus ion formed. You know that. By the reaction of rainwater with carbon dioxide and which is present in the atmosphere. That is, the reaction is H2O, water plus carbon dioxide gives bicarbonate, and bicarbonate is H plus and released into bicarbonate ion. When the pH of the rainwater drops below 5.6, it is called acid rain. Okay, now acid rain refers to the ways in which acid from the atmosphere is deposited on the earth's surface. Oxides of nitrogen and sulfur, which are acidic in nature, can be blown by wind along with solid particles in the atmosphere and finally settle down either on the ground as dry deposit or in water, fog, and snow as wet deposit. Okay, now acid rain is a byproduct of variety of human activities that emit the oxide of sulfur and nitrogen in the atmosphere. As mentioned earlier, burning of fossil fuel which contains sulfur and nitrogenous material such as coal, oil in power station and furnaces, or petrol and diesel in motor engine produce sulfur dioxide and nitrogen oxides. SO2 and NO2 after oxidation and reaction with water are major contributors to acid rain because polluted air usually contains particular matter that catalyze the oxidation, that is 2SO2 plus O2 plus 2H2O gives 2H2SO4 sulfuric acid and 4NO2 plus O2 plus 2H2O gives 4HNO3, that is nitric acid. Now, ammonium salts are also found and can be seen in the atmosphere as an atmospheric haze. that is aerosol of fine particle. Aerosol particles of oxides or ammonium salt in raindrop result in wet deposition. SO2 is also absorbed directly on both solid and liquid ground surface and is thus deposited as dry surface. Okay, next let us learn about particulate pollution. So particulate pollution are minute solid particles or liquid droplets in air, and these are present in vehicular emission, smoke particles from fires, dust particles, and ash from industries. Particles in the atmosphere may be viable or non-viable. The viable particles, example bacteria, fungi, moths, algae, etc., are minute living organisms that are dispersed in the atmosphere, and human beings are allergic to some of the fungi found in air, and they can also cause plant diseases. And you see, non-viable particles may be classified according to nature and size, which are given as follows. This and yeah, over here, D. Now, what this point A says is that smoke particulates consists of solid or mixture of solid and liquid particles formed during combustion of organic matter. Now, examples are cigarette smoking, smoke from burning fossil fuel, garbage and dry leaves, oil smoke. Now, dust is composed of fine solid particles over 1 micrometer diameter, produced during crushing, grinding, and attribution of solid materials. Sand from sandblasting, sawdust, and from woodworks, pulverized coal, cement, and fly ash from factories, dust storms, etc. are some typical example of the type of particulate emission. And see, mists are produced by particles of spray, liquid, and condensation of vapors in air. Examples are sulfuric acid mist, and they are herbicides and insecticides that miss their targets and travel through air and form mists. Now, fumes are generally obtained by condensation of vapors during sublimation, distillation, boiling, and several other chemical reactions. Generally, organic solvents, metals, and metallic oxides form fume particles. Okay, now let us study about smog. See, there are two types of smog. I hope you know what is smog. Fog plus smoke gives smog. Now, classical smog and photochemical smog. See, classical smog occurs in cool, humid climate. It's a mixture of smoke, fog, and sulfur dioxide. Chemically, it is reducing mixture and is also known as reducing smog. Now, photochemical smog occurs in warm, dry, and sunny climate. The main components of photochemical smog result from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Photochemical smog has high concentration of oxidizing agent and is therefore called oxidizing smog. Now, formation of photochemical smog. When fossil fuels are burnt, variety of pollutants are emitted into the earth, and they are emitted into the troposphere. Two of the pollutants that are emitted are hydrocarbons, that is unburned fuel, and nitric oxide, NO. When these pollutants build up to sufficient high level, a chain reaction occurs and an interaction with the sunlight, in which NO is converted into nitrogen dioxide, NO2. This NO2 in turn absorbs energy from sunlight and breaks up into nitric oxide and free oxygen atom. The reaction is given over here. Oxygen atoms are very reactive and combine with O2 in the air to produce ozone. Oxygen combined with O2 to produce ozone. The ozone formed in the above reaction reacts rapidly with NO gases formed in the reaction to regenerate NO2. NO2 is a brown gas and at sufficiently high level can contribute to haze. That is NO plus O3 gives NO2 plus NO2, O2. This forms haze. Ozone is toxic gas and both NO2 and O3 are strong oxidizing agent and can react with unburnt hydrocarbon in polluted air to produce such chemicals such as formaldehyde, acronyl, and peroxyacetyl nitrate, that is PAN. They might ask this question, PAN. C is 3 methane plus 2O3, that is ozone, gives 3 CH2 double bond O plus 3 H2O, that is formaldehyde in this. And this is the formula of acronyl. And this is PAN, formula of PAN. Now let us study what is the effect of photochemical smog. See, the common components of photochemical smog are ozone, nitric oxide, acronyl, formaldehyde, and peroxyacetyl nitrate, that is PAN. Photochemical smog causes serious health problems. Both ozone and PAN act as powerful eye irritants. Ozone and nitric oxide irritates the nose and throat, and high concentration of of that causes headache, chest pain, dryness of throat, cough, and difficulty in breathing. Photochemical smog leads to cracking of rubber and extensive damage to plant life. It also causes corrosion of metal, stones, building materials, rubber, and painted surfaces. Okay, next, how can photochemical smog be controlled? There are many techniques used to control or reduce the formation of photochemical smog. If we control the primary precursor, that precursor, you know what is precursor? Precursor is the main reason, that is the first reason due to which smog is formed, or anything is formed, it's called precursor. A primary precursor of the photochemical smog such as NO2 and hydrocarbons. The secondary precursors such as ozone and pan, the photochemical smog will automatically be reduced. Usually catalytic converters are used in automobile which prevent the release of nitrogen oxide and hydrocarbon into the atmosphere. Certain plants such as example Pinus, Juniperus, Quassus, Pyrus and Vitis can metabolize nitrogen oxide, and therefore their plantation could help in this matter. Okay, now next topic is stratospheric pollution. Let us see the formation and breakdown of ozone. This is the molecule of oxygen, and presence of UV breaks down into O, and this O gets and combines with another oxygen to form ozone. See, first of all, ozone is thermodynamically unstable and decomposes to molecular oxygen. Thus, a dynamic equilibrium exists between the production and decomposition of ozone molecule. In recent years, there has been reports of the depletion of this protective layer because of the presence of certain chemicals in the stratosphere. The main reason of ozone layer depletion is believed to be the release of CFCs, chlorofluorocarbon compounds, also known as freons. These compounds are non-reactive, non-flammable, non-toxic organic molecules and therefore used in refrigerator and air conditioner. See, what happens is that in the production of plastic foam and by electronic industry for cleaning computer plants, etc. Once CFCs are released in the atmosphere, they mix with the normal atmospheric gases and eventually reach the stratosphere. In stratosphere, they break down by powerful UV radiation releasing chlorine-free radical, that is, this is CFCs, chlorofluorocarbon, that is CF2Cl3. In the presence of UV gives Cl radical and this radical, CF2Cl radical. The chlorine radical then reacts with stratospheric ozone to form chlorine monoxide radical and molecular oxygen. This chlorine radical reacts with ozone to give chlorine oxide radical and oxygen. A reaction of chlorine monoxide radical with atmospheric oxygen produces more chlorine radical. See, when chlorine oxide reacts with molecular, that is chlorine monoxide radical, which reacts with atmospheric oxygen, produces chlorine radical and O2. Now the chlorine radicals are continuously regenerated, this radical, and cause the breakdown of ozone. Due to this, the CFCs are transporting agents for continuous generating chlorine radical into stratosphere and damaging the ozone layer. Now let us study something about the ozone hole. What happens in the ozone hole is that in summer season, that is nitrogen dioxide and methane react with chlorine monoxide from reaction 4 and chlorine atoms, reaction 5, forming chlorine sinks, preventing much ozone depletion. Whereas in winter, special types of clouds called polar stratospheric clouds are formed over Antarctica. And these polar stratospheric clouds provide surface on which chlorine nitrate formed, that is reaction 4, gets hydrolyzed to form hypochlorous acid. In the reaction 6, it reacts with hydrogen chloride produced as per the reaction 5 to give molecular chlorine. And this is the reaction of that, just read it, okay? Okay, now when the sunlight returns to Antarctica in the spring, the sun's warmth breaks up the clouds and COCl2 and Cl2 are fertilized by sunlight as given in the reaction 8 and 9, that is HOCl in the presence of H nu gives OH minus OH radical and Cl radical, and Cl2 in presence of H nu gives Cl2Cl radical, and chlorine radical does form initiate chain reaction of ozone depletion as described earlier. Effect of depletion of ozone layer. See, with the depletion of ozone layer, more UV radiation filters into the atmosphere. UV radiation leads to aging of skin, cataract, sunburn, skin cancer, killing of many phytoplankton damage to fish productivity, etc. It has also been reported that the plant proteins get easily affected by UV radiation, which leads to harmful mutation of the cell. It also increases evaporation and of surface water to the stomata of leaves and decreases the moisture of the content of the soil. Increase in UV radiation damage plants and fiber, causing them to fade faster. Now let us read something about water pollution. See, easily identified source or place of pollution is called point source. Example, municipal and industrial discharge pipes, where pollutants enter the water, and non-point source are the pollutants where the source of pollution cannot be identified. Example, agricultural runoff from farm animals and croplands, and acid rain, storm water drainage from street, parking lot and lawns, etc. These are listed in the table. Read this table. Okay, now causes of water pollution. Okay, now let us see the major source of water pollutants, that is microbes, organic waste, plant nutrient, toxic heavy metals, sediment, pesticides, radioactive substances, heat. Now, microorganisms are from domestic sewage, organic waste or domestic sewage, animal excreta, waste, decaying animals, plants discharge from food processing factories. Now, plant nutrients are chemical fertilizers. Toxic heavy materials are industries and chemical fertilizers and factories. And sediments are erosion of soil by agriculture and strip mining. And pesticides are chemicals used for killing insects, fungi, and weeds. Radioactive substances, mining of uranium containing minerals, and heat water used for cooling in industries. Now let us come for the causes of water pollution, that is pathogen and organic waste. See, what happens is that human excreta contains bacteria such as Escherichia coli and Streptococcus faecalis, which causes gastrointestinal diseases. And organic waste, they pollute the water as a consequence of runoff. Excessive planktonic growth within water is also a cause of water pollution. These wastes are biodegradable. The large population of bacteria decomposes organic matter present in water. They consume oxygen dissolved in water, and the amount of oxygen that the water can hold in the solution is limited. Okay. Now what happens is that in cold water, dissolved oxygen DO can reach concentration up to 10 parts per million, whereas oxygen in air is about 2 lakh parts per million. This is why even moderate amount of organic matter when decomposed in water can deplete water whilst dissolved oxygen. The concentration of dissolved oxygen in water is very important for aquatic life. If the concentration of dissolved oxygen is below 6 parts per million, the growth of fishes gets inhibited. Oxygen reaches the water either through atmosphere or from the process of photosynthesis carried out by many aquatic green plants during daylight. However, during night, photosynthesis stops, but the plant continues to respire, resulting in the reduction of dissolved oxygen. And the dissolved oxygen is also used by microorganisms to oxidize organic matter. If too much of organic matter is added to water, all the available oxygen is used up. This causes depletion of aquatic life to die. Thus, anaerobic bacteria which do not require oxygen begin to break down the organic waste and produce chemicals that have foul smell and are harmful for human health. Aerobic bacteria, oxygen requiring, degrade this organic waste and keep water depleted in dissolved oxygen. So thus the amount of oxygen required by bacteria to break down the organic matter present in certain volume of sample of water, known as biological oxygen demand, that is BOD. The amount of BOD in water is measure of amount of organic material in the water in terms of how much oxygen will be required to break down biologically. Clean water would have a BOD value of less than 5 parts per million, whereas highly polluted water could have a BOD value of 17 parts per million. And third one is chemical pollution. As we know that water is an excellent solvent. Water soluble inorganic chemicals that include heavy metals such as cadmium, mercury, nickel, etc. constitute an important class of pollutants. All these metals are dangerous to humans because our body cannot excrete them. Over time it crosses the tolerance limit. The metals can damage kidney, central nervous system, liver, etc. Acids like sulfuric acid from mine drainage, salts from many different sources, and including raw salt used to melt snow and ice in colder climate, that is sodium and calcium chloride, are water soluble chemical pollutants. Okay, the organic chemicals are another group of substances that are found in polluted water. Petroleum products pollute many sources of water, example major oil spills in ocean. Other organic sources with serious impacts are the pesticides that drift down from spray or runoff from land. Various industrial chemicals like polychlorinated biphenyls, that is PCBs, which are used as cleansing solvents, detergents and fertilizer, add to the list of water pollutants. PCBs are suspected to be carcinogenic. Nowadays, most of the detergents are available are biodegradable. However, they can create other problems. The bacteria responsible for degrading biodegradable detergent feed on it and grow rapidly. While growing, they may use up all the oxygen dissolved in water. The lack of oxygen kills all other forms of aquatic life such as fish, plants. Fertilizer containing phosphates as additives. The addition of phosphates in water enhances algal growth. Such profuse growth of algae covers the water surface and reduces the water concentration in water. Reduces oxygen concentration in water. This leads to anaerobic condition, commonly with accumulation of obnoxious decay and animal death. Thus, bloom infested water inhibits the growth of other living organisms in the water body. This process, in which nutrient-enriched water bodies support a dense plant population, which kills animal life by depriving it of oxygen and results in subsequent loss of biodiversity, is known as eutrophication. Okay, next topic is international standard for drinking water. First one is fluoride. Next is lead, then sulfides, nitrates and other metals. Okay, fluoride. For drinking purposes, water should be tested for fluoride ion concentration. Its deficiency in drinking water is harmful to man and causes diseases such as tooth decay, etc. Because fluoride is important. Soluble fluoride is often added to drinking water to bring its concentration up to 1 parts per million or 1 mg or dm raised to the power minus 3. And the fluoride ion make the enamel on the teeth much harder by converting hydroxyapatite, that is 3Ca3PO4, that is calcium phosphate dot CaOH twice. Okay, that is the enamel on the surface of the teeth into much harder fluoroapatite, that is 3 calcium phosphate dot CF2. Okay, however, F minus ion concentration above 2 parts per million causes brown motting of teeth. At the same time, excess fluoride over 10 parts per million causes harmful effect to bones and teeth, as reported from some parts of Rajasthan. Okay, lead. Drinking water gets contaminated with lead when lead pipes are used for transport of water. The prescribed upper limit concentration of lead in drinking water is about 50 parts per billion. Not million, it's billion. Lead can damage kidney, liver, reproductive system, etc. Now, sulfate. Excessive sulfate that is greater than 500 parts per million in drinking water causes laxative effect. Otherwise, at moderate level, it is harmless. Nitrate. Maximum limit of nitrate in drinking water is 50 parts per million. Excess nitrate in drinking water can cause disease such as methanohemoglobin, blue baby syndrome, and other metals. Maximum concentration of some common metal recommended in drinking water is given here, and it's not important to know that. Okay, next let us come to the next topic, and that is pesticides. Prior to World War II, many naturally occurring chemicals such as nicotine by planting tobacco plants in copper field were used as a pest controlling substance for major crops in agriculture. In World War II, DDT was found to be of great use to control malaria and other insect-borne diseases. Therefore, after the war, DDT was put in agriculture to control damage caused by insect, rodent, weed, and various crop diseases. However, due to adverse effect, its use has been banned in India. Pesticides are basically synthetic toxic chemicals with ecological repercussions. The repeated use of the similar pesticide gives rise to pests that are resistant to group of pesticides and thus making pesticides ineffective. Therefore, an insect resistance to DDT increases. Other organic toxins such as aldrin and dieldrin that were introduced in the market by pesticide industry. Most of the organic toxins are water soluble and non-biodegradable. See, these highly persistent toxins are therefore transferred from lower trophic level to higher trophic level to food chain like this. Over the time, the concentration of toxin in higher animals reach a level where serious metabolic and physiological disorders occur. Now, in response to higher persistence of chlorinated organic toxins, a new series of less persistent or more biodegradable products called organophosphates and carbamides have been introduced in the market. But these chemicals are severe nerve toxins and hence more harmful to humans. As a result, there are reports of some pesticides-related death of agriculture field workers. Insects have become resistant to insecticide also, and insecticide industry is engaged in developing new group of insecticides. But one has to think, is this is the only solution to pest menace? Is this only solution to pest menace? In these days, insecticide, that is pesticide industry, has shifted to attention to herbicides such as sodium chlorate NaClO3, sodium arsenate Na3ASO3, and many others. During the first half of the last century, the shift from mechanical to chemical weed control had provided the industry with flourished economical market. But one must remember that these are not environment friendly. These are also not environment friendly. Most herbicides are toxic to mammals but are not as persistent as organochlorides. These chemicals decompose in few months like organochlorides. This too becomes concentrated in food web. Some herbicides cause bird defects. Studies show that the cornfields sprayed with herbicides are more prone to insect attack and plant disease than fields that are weeded manually. Pesticides and herbicides represent only a very small proportion of widespread chemical pollution. A large number of other compounds are used regularly in chemical and industrial process for manufacturing activities and are finally released into the atmosphere in one or the other form. Now let's study the last topic, that's industrial waste. Industrial solid wastes are also sorted out as biodegradable and non-biodegradable waste. Biodegradable wastes are generated by cotton mills, food processing units, paper mills, and textile factories. Non-biodegradable waste are generated by thermal power plants, which produce fly ash, integrated iron and steel plants, which produce blast furnace slag and steel melting slag. Industries manufacturing aluminum, zinc, copper produce mud and tailings. And fertilizer industry produce gypsum. Hazardous waste such as inflammables, composite explosive or highly reactive substances are produced by industries dealing in metal, chemicals, drugs, pharmaceuticals, dyes, pesticides, rubber goods, etc. Disposal of non-biodegradable industrial waste, if not done by proper and sustainable method, may cause serious threat to the environment. The innovation have led to different use of waste material. Nowadays, fly ash and slag from steel industry are utilized by cement industry. Now the large quantities of toxic waste are usually destroyed by controlled incinerations, whereas small quantities are burnt along with factory garbage in open bins. More solid waste, if not managed effectively, affect components of the environment. Now let us study the strategies to control environmental pollution. First one is waste management. See, you must have been aware of the Swachh Bharat Abhiyan or Clean Mission, Indian mission, launched by Government of India. Two programs are being implemented under the broad umbrella of Swachh Bharat Abhiyan. These are Swachh Bharat Mission Urban, that is SBMU, and Swachh Bharat Mission Gramin, SBMG. And the SBMU primarily aims at making urban India free from open defecation and achieving 100% scientific management of solid waste in the country. The SBG targets to bring about an improvement in general quality of life in rural areas by promoting cleanliness and hygiene and eliminating open defecation. It is accelerating its effort to achieve the goal of universal sanitation coverage by 2nd October 2019, which is birth anniversary of Mahatma Gandhi. If you have participated in some events, such what, write your experience. And you can see the chapter comes to an end. Okay, there is one small part, that is green chemistry. And in green chemistry, you see there are 4 kinds. One is dry cleaning of clothes, bleaching powder, or not bleaching powder, bleaching of paper, and synthesis of chemicals and green solution to clean turbid water. Now let us see the dry cleaning of clothes. It occurs by tetrachloroethane, that is Cl2C double bond CCl2, which was earlier used as solvent for dry cleaning. The compound contaminates the groundwater and is also a suspected carcinogen. Okay, the process used by this compound is now being replaced by a process where liquefied carbon dioxide with a suitable detergent is used. Replacement of halogenated solvent by liquid CO2 will result in less harm to groundwater. These days, hydrogen peroxide H2O2 is used for the purpose of bleaching clothes in the process of laundry, which gives better result and makes use of lesser amount of water. Now bleaching of paper. Chlorine gas was used earlier for bleaching paper. These days hydrogen peroxide H2O2 was with a suitable catalyst which promotes the bleaching action of hydrogen peroxide is used. Now synthesis of chemicals. What happens is that ethanol, that is CH3CH2, is now commercially prepared by one-step oxidation of ethane in the presence of ionic catalyst in aqueous medium with the yield of 90%. And CH2 double bond CH2 plus O2 in the presence of catalyst, that is palladium 2 copper 2 in water, gives CH3CHO and 90% is obtained, that is concentrated. Now green solution to clean turbid water. Powder of kernel of tamarind seeds has been found to be an effective method to make municipal and industrial wastewater clean. It is non-toxic, biodegradable and cost-effective method. This powder is usually discarded as agricultural waste. The present practice is to use alum to treat such water. It has been found that alum increases toxic ion in treated water and can cause diseases. Green chemistry in a nutshell is a cost-effective approach which involves reduction in material, energy consumption and waste generation. Thank you. I have always told you that question practice is the most important part of chemistry and need to solve them to improve your concepts. Thank you. These are its answers and have a nice day. Okay guys, if you like my video, do hit the bell icon and subscribe button so that you will be notified with all upcoming videos, which is fully free, and enjoy unlimited lectures. Thank you.